Before you can efficiently make your own custom clouds and really define what it is that you want to do with them, it's really good to understand exactly how the cloud system works and exactly what settings do what. So I want to show you and just kind of go through exactly what it is that makes a cloud. You can load in the scene that comes with the training. It's called Start Scene 1 to get the scene I currently have loaded up. It's just basically a default atmosphere with a ground plane with one of my custom grass materials on it. The camera I have set up to a focal length of 22.3. It shows as 22, but it's actually 22.3, which is about the equivalent human eye, one eye, not with both of them. So we will be able to see a fairly good amount of the sky. We can start by going into the atmosphere editor, F4 on the keyboard, if you want to use the shortcut. And there is one other thing I want to note, and is that I am using an internal unit. If you go to File and Options, Units and Coordinates, an internal unit of 1 meter. This is really important because it controls all of the units within the different editors and the final display output of each of the materials, any function, and also has a huge impact on the atmosphere itself. I'm going to add in one of the Spectral 2 clouds. We can just load in the Stretch Stratus. We're going to be customizing it. And what I want to do to customize this is remove most of the altitude variation and start by having a detail amount of 0. Altitude at 1 kilometer, height at 1 kilometer. I'm going to change the cover to 55%. And now what we can do is right-click to edit the material. And I'm going to right-click where we have the function, and right now you can see it's just a basic repeater. I'm going to right-click and reset that function. I'm also going to right-click and reset the filter. The function scale is set to 2 on the X, and then it's minimized on the Y and Z. I'm going to go ahead and set all of these to 1 so that we're working with pretty much a pure material to start out with. If we go over to Lighting and Effects, we can see that the lighting model is set to the volumetric layer version 2. Version 1 would be the technology that was created around the release of version 6, so that's Spectral version 1. We're going to be using Spectral version 2. And I'm going to keep on the internal shadows, cast shadows, and the GI ambient lighting. Going over to the color and density, if we take a look at the cloud layer detail, these settings are directly controlled, or total control of this and the final output is controlled by the detail amount in the cloud tab. So if the detail amount is set to 0, as it is right now, what we're going to see is the pure density function along with the cloud layer profile. So let's go ahead and edit the function, and we're going to create something custom. The output observer that's going to show up for the material preview may not be all that accurate. It's really more of a representation of a volumetric cloud or a 2D layer cloud. It can give you some idea of what the layer will look like, but it may be a bit off. So I'm going to start with something very simple, which is basically adding in a noise node. And we're going to connect the density to the output of this default noise that's created. I am going to change this over to a different shape. We're going to use a math pattern tooth Gaussian. What this is basically a sphere, a volumetric sphere, and with no detail, we should see, once we close all this out, just a cloud sphere up in the top. Now, depending on the height, it's not necessarily going to be a sphere because it is being squished at this point. And I am going to go ahead, move the camera out, and if you take a look at a render, what we're seeing is just the density created by the noise. Without the detail setting, turned on, there is no detail subtraction, which is one of the primary ways or looks of the cloud layer. Really, depending on what you want to make, it's what creates all the fine little details, although it doesn't have to. It is possible to create an entire cloud layer with just these density settings. I'm going to go ahead and zoom out a little bit more. And if we go into the atmosphere editor and take a look at the cover amount, what this is going to do is define how much of that density production for the material is impacting the cloud layer, and exactly where it's going to be cut off. So at 55%, it's being cut off a little bit sooner. If we bring it up to 100%, we're going to see basically the full fractal with all of the fall off as well. So if I just do a quick preview render, you're going to see a lot of noise. There are a lot of reasons for this noise. At the moment, Quality Boost would remove that, but there are more efficient ways of creating clouds to remove noise. And we'll take a look more specifically at noise removal as we go through the training. But let's go ahead and set this cover amount back down to 55. And now we can adjust the height. We're not going to see much of an impact by changing the height because we're still restricted by the density production and the scale of that output. You also notice we have a material scale over here, which is set to 2. Now I'm going to go ahead and set this to 1, and we can zoom in a little bit more to get back to just that cloud. Now we have another setting that is impacting this, which is the feather amount. I'm going to reduce the feathers. We'll just go ahead and take sharpness and feathers and move them down to 5% for now. So there's not a whole lot of impact. Like I said, the height, even though we're seeing the value is set to 3.6 kilometers, and if we take a look in the side view, what we'll be able to see is the full volume of the cloud. Well, it's not actually filling that much space. And if we take a look at the camera, which has the sun connected to it, we're within that cloud layer. And you really only see the bottom portion showing up. So if we did want to make this sphere, what we could do is go into the density production, and we're not really seeing the lower half, just kind of the upper portion of the noise. So the easiest way would really be to adjust the cloud profile. We'll take a look at that in just a minute. Go ahead and close that out. But I do want to show you exactly what happens when we start to bring in a little bit of detail. So let's take the detail amount and set it to 25, which is going to be 25%. And what we're going to start to see is a subtraction around that noise. So here we can see the render and that circle having the edges removed by the detail function, which is an internal function that can only be edited by the sliders that are shown. I am going to change and set up an auto exposure for now, because auto exposure wasn't turned on when the render completed. It's not going to apply. So I can just reduce the exposure, and that way we can take a look at the cloud a little bit better. So in order to adjust this subtraction, what we do is go back into the atmosphere editor, and we can increase the detail amount to control and basically see how much is going to be removed. And then we have a scaling, a roughness, variations, and uniformity. These 4 settings entirely control the detail amount, and that's part of the internal function. That also applies to volumetric layer 1. So if we're using Spectral 1 clouds, same exact thing is going to happen, where that subtraction is controlled by these 4 major sliders, and the total amount of subtraction is controlled by the detail amount. Because of this, it is possible to just display the cloud layer detail, and you don't even need to have a density production if you just want to show the detail layer. So what I can do to preserve this every once in a while, if there's no connection to some of the nodes, depending on what area the program you're working in, sometimes it will remove anything without a connection to an output. So I'm instead going to create a blender instead of just removing the connection. We're going to set the ratio to 1, which is going to be input 1, which is currently not connected to anything. So that's going to return a value of 0. So now what we're going to see is just the detail layer, provided we have some of the other settings applied, which means we may need to increase cover. And now we're going to see just this detail, and if we go ahead and increase that a little more, we can see more of the detail layer. Now, this is taking a little bit too long to render, so I'm going to just close this out and reduce the height of the cloud layer, which should give us a much faster render. So what we're seeing is a very uniform cloud layer. Because the amount of density that we control with the function ranges between -1 and 1, the output of 0 is a medium level of density. And then we're subtracting from that medium level with the roughness amount. So controlling the settings for the detail, the cloud layer detail, really has a huge impact on cloud layer depending on the detail amount. If we increase the scale, it's going to increase the overall scale of that subtraction and that detail subtraction. So even without any sort of noise to control the initial density, and just using the detail layer, you can still create very nice looking clouds. And in fact, it creates a fast rendering cloud. Now, the scale is directly impacted by the scale of the material. So if we were to change the material scale to, say, 0.5, it's going to reduce that detail internal fractal, and also reduce anything you have in the density production that's creating the other shapes for the clouds. So because of this, you need to be careful how you're adjusting the overall scaling amount of the cloud layer detail in relation to the material size, which also shows up at the top of the material here, and also pay attention to the roughness. Now these two sliders, you can sometimes get some of the best results, at least when you're controlling the overall shape of the density, by having one up and one down. So if scaling is up, reduce roughness. If scaling is down, increase roughness. Roughness is a very interesting setting. Once you hit an amount past 50%, it does create a very large impact. But you'll really see that more with a density production. So we can't really see it right now. I'm going to go ahead and increase the roughness and scaling up to a very high amount, 100% for each, and then reduce the cover amount, which we can see starts to reduce whatever is being shown in the noise, which is currently a value of 0. And let's go ahead and take a look at that, which is probably going to be way too grainy. Another thing to keep in mind is you can see a huge difference between the preview render, the main camera, and also the full render. And that's because the preview render is calculated differently, and the scales are going to be a little bit off. So depending on what it is you're working on, don't always want to rely on the main camera preview. Sometimes it's quicker just to render something out a little bit larger or render the view. So right now we can see an extremely large amount of grain and roughness because the roughness setting is just set way too high, which isn't going to really work for this. Even with another type of noise in there, it's going to cause some problems. But now with a very small amount of roughness, and basically it's just like the roughness of a regular fractal, if you work with any of the fractal nodes at all. Adjusting the scaling, we can now see these huge gaps between the clouds, and that overall the detail is just very minimal. Increase the cover, and it's going to increase that cloud amount, but we're still going to have these larger separations and not a lot of detail because the roughness setting is very low. So we're just really looking at this detail subtraction layer. To see the layer fully, we would need to increase the detail amount to 100%, and then we're going to end up with something a little bit sharper. And in this case, a lot more grain around the edges of the clouds and the shadows. So let's go ahead and bring some of these values back to what they were before. Cover of 55, detail amount 25. I'm going to go ahead and edit the material, and let's take that blender and set it to 0, which is going to bring back that noise we were using before. Take the scaling, bring it down to 20, roughness 35, bring down the variations to 5, and let's take a look at the uniformity of cloud layer detail and really get into looking at the custom layer profile, which can be a very important part of controlling the shape of a cloud. So we just need to move the camera back to being above this layer and this noise circle, and just want to be able to see a good deal of it. So with the roughness, it still looks a little interesting in the preview. Probably look a lot better in the full render. Let's take a look. So with the scaling of the detail layer being so small, we can get away with a higher amount of roughness without it destroying the overall cloud look and not producing too much grain. So we can increase the roughness to 50%, look a little bit better. The uniformity is basically the flattening of the cloud along the bottom and pretty much what gets cut off. So if I set the value to 0, and we'll probably have to look at this from the side of the cloud in order to see it best. And I'll need to increase the height as well. I'll go ahead and increase the height of the cloud layer, which is also moving through the overall noise. Because uniformity is a detail setting, we do need to increase the detail amount to be able to see it fully. I'm going to increase the cover in order to have more of an impact of the shape of the noise. So let's take a look with a value of 0, which should be a lot flatter on the bottom of the cloud layer. So with the uniformity amount set to 0, we have a more uniform shape at the bottom of the cloud layer, where you're not going to see as much of the detail settings or even the noise in some cases, and it's just going to kind of flatten everything out. We're still seeing an overall kind of dip in the cloud. That's mainly caused by the perspective at the current camera angle, but also because of the initial noise itself and its shape. The more we increase the uniform amount, we'll start to be able to see those areas on the bottom of the cloud come back and that detail amount. So if you're looking for a flatter cloud layer on the bottom, you can reduce the uniform scaling or the uniform percentage, provided you're using enough detail or enough of the detail slider. So you can see it's really acting more like a height for the subtraction from the bottom. So with the amount set to 100, there'll be no flattening of the cloud layer on the bottom. So that way you can create a lot of different shapes that way. Now, the fuzzier edges we're seeing of the cloud are caused by the density production, because the Gaussian is a Gaussian noise that has a huge fall off around the edges. If we use one of the other settings, let's go ahead and change it to We could do rectangular. This is going to give us a huge cutoff. There's going to be no minimal amount of density around the edges, so we're just basically dealing with a full density and no density at all, which is going to give us some very harsh edges, and we can also start to see the cloud profile a little bit more, which means you'll also see, as you start to see that showing up, a very harsh cutoff around the edges, and it's creating kind of a problem with the roughness, where it's causing a lot of grain. But what we're seeing is basically that noise all the way up on top. And if we go ahead and take the uniformity and set it to 0, we're going to see it flatten out a lot more on the bottom as before. I'll just do a preview render of that. Detail amount set to 100%. You can see it a little bit more, along with the detail layer subtracting from the bottom. But it's a very harsh cutoff overall. We can adjust the cover amount, and if we reduce it, it's going to reduce the total output of that noise. But like I was saying, when you have that very harsh cutoff within the noise itself, there really is no blend, and you're going to have very harsh edges around any cloud. So let's take a look at the cloud profile. And I'm going to increase our cover amount to 100%. And I'm going to go ahead and switch this back to the tooth Gaussian and use a filter. So if we edit this filter for the noise, we just add a few points and kind of cut out the top and bottom a little, which is going to be more of the fall-off area. And a lot of grain, I do want to note that, is caused by that in-between area where there's not enough volume, just very little volume in the area, and it's just reacting badly with the light or with the roughness settings. So let's go ahead and turn down the uniformity. I am going to turn off the cloud layer profile for the moment, increase the height so we can see a little bit more of this cloud and the noise. Our detail amount we can reduce. Let's just take a look at this as it currently is. So with just the default setting, no custom filter, we have a very mostly uniform cloud, just kind of a circle. And if we take a look, this filter that we have for the density production controls the total output of this density. Now the cloud layer profile is a filter that is the overall height is controlled by the height amount, and the overall impact of the cloud layer profile is controlled by this actual height rather than it directly impacting the density production. So I'm going to reset the filter, turn on the custom cloud layer profile, right click, reset the filter. We're going to see something, in this case, disappear completely because of the way the output is. It's not your typical filter where you would have going from the bottom all the way to the right and the upper top. Basically, in order to really view this properly, you would need to rotate it 90 degrees and view it vertically. And that's the way you would really view the cloud profile. So if we double-click to create a point and move that all the way to 1 and just have a straight profile, we're going to see a very even distribution of the edges. And now pretty much the entire noise by itself and no subtraction whatsoever. So the more we modify this filter, kind of create a dip, really depending on what part of the noise is showing up in relation to the height amount, we can kind of dip that in. And now you can see a subtraction of the density around the edges, so adjusting the cloud profile. And this works kind of going around the cloud or any of the density areas. Once we fall below 0, we're going to have pretty much no density in this case. And what would happen is if we had a high enough roughness setting, we're going to see more roughness in the area. So if we keep it around 0.5, we're just going to have a smaller dip. So very tiny amounts and changes within the profile can severely impact this. You can also see the range too. We're basically kind of falling between -1 and -0.5 for the cloud existing within the total height amount. So it's only a really small amount showing within that total volume. If we take a look in the front view from the side, it's only really raising up a very small amount compared to the total height of the layer. So if we turn this on to curves, we're going to see more of a nonlinear dip. If we reduce the amount, we just have something very subtle. You just notice that tiny bit of subtraction compared to as it was before. So now if we start bringing down the other side, now since there's really no volume in this upper area, the impact of this basically going to cut off at the 0.5 amount, -0.5 or so. I'm just going to go ahead and drag this down, even though it's really not going to impact it, just to give a better idea of how that's going to look. And we can start to see a little bit of subtraction around the top. So you can shape your clouds with the profile as well. And really add a lot more detail and customization to the shape. But it still exists within its normal fall-off amount. If we wanted to raise this up and get rid of that round noise look, we can increase the Z scale, which is going to change basically the noise height, and we're going to see more of the cloud layer profile active. And depending on the cover and the density of the detail, you're going to be able to create a lot of custom variation within your cloud layer that way. So that's just kind of a basic overview of the main controls of the cloud layers. What kind of does what. We'll look more in depth and start creating some much better looking cloud layers. And then you'll be able to get a lot better of a grasp of exactly how to create specific cloud shapes.